Sections 3.3 is other common functions. These are functions that you need to know the shape of the function. And they're all, on this slide at least, they're all polynomials. Polynomials with only one term, so they're actually what we call monomials. So f of x equals x to the n, where n is a positive integer. So for n equals 1, we get f of x equals x, or y equals x. That's a line. And notice it goes through the point 0, 0, and it goes through the point 1, 1. So in other words, if you go from here, if you go over 1 and up 1, you get another point on the line. For n equals 2, we get this parabola, right, with the vertex at the origin. And if you go to the right one, you go up 1, you get another point. To the left one and up 1, you get another point. And that's because the coefficient on the x squared is a 1. For n equals 3, we get a cube function, the cube function. And this kind of looks like a parabola with the left-hand side turned upside down instead of continuing up. It's not really the same shape. It's actually flatter in here than the parabola is and steeper over here than the parabola, but it has the same basic shape. And here what you do is the leading coefficient's 1, right? So you go, in fact, it's the only coefficient, it's 1. So you go right 1 and up 1. If that was 2 in front of the x cubed, I'd go right 1 and up 2, and that point would be a point on the graph. The difference between this and the parabola is if you go to the left 1, you have to go in the opposite direction of a. So if a being the coefficient of x cubed, if a were negative, you would actually be going up. And here you would have been going down. So this would be reversed like this. Right? So if a is positive, it would look like this. And how far down? So like if a was 2, you would go left 2 and down 2. So the left side goes the opposite direction as the right side for n cubed. For the fourth power, it looks very much like a parabola, except it's flatter on the bottom. And, you know, I'm just drawing this freehand, so you can't tell so well, but it's flatter on the bottom. But the same rule works if you go to the right 1 and up 1. I didn't put my notches there, but if you go right 1 and up 1 with a leading coefficient of 1, you get another point on the graph. So you would graph these the same way you would graph x squared, basically. And n to the fifth looks like the cube root, except it gets steeper faster, and it's flatter near the origin than the cube root is. Actually, I did a pretty good job drawing that one. And that continues, alternating types between even and odd values of n. And n is the exponent, right? So that gives you all of the single term polynomials. In other words, all the monomials with a positive exponent. They all look like one of these.